warriors. Welcome back to the channel. Today is day 5 of the test series and today's chapter is Mole Concept. I'm sure you would have received the test paper yesterday on the Telegram channel. If you are not still aware of the concept, go ahead, join the Telegram channel. You receive the test paper a day before the test is discussed. So you get a whole day to try out the questions on your own and then connect on the video to understand what answers you wrote and what are the expected answers in the board examination. So, without wasting any more time, let's get started. Alright students, let's get started. So, the reason why this question paper has different numbering pattern here is because the initial question paper that I had, a lot of portion was cut out from the syllabus. So, I had to crop it and make a new test paper. So that is the reason all the numbers are up and down. So don't worry about the question numbering pattern. Okay, so we'll start with the first question. So the first question says that calcium carbide is used for the artificial ripening of fruits. Actually, the fruit ripens because of the heat evolved, while calcium carbide reacts with moisture. Okay, not so important information in the question. Now, during this reaction, calcium hydroxide and acetylene gas is formed. Now, from here, you have the important information. If 200 centimeter cube of acetylene is formed from a certain mass of calcium carbide, find the volume of oxygen required and carbon dioxide formed during the complete combustion, and the equation is given to you. Okay, so let's get started with the question. So I'll be wherever I find space, I'll be solving the question there. If I don't, I'll be adding another sheet towards the end of the test paper. Now, let's get started. So, the equation that we have is twice of C2H2, that is acetylene. Let me write it over here. Okay. So, twice of C2H2 plus 5 oxygen is giving me 4 CO2 plus 2 H2O. Okay, so this is the equation that is given to me. Now we'll start with the basic understanding that if 2 volume of acetylene, I'm not writing completely, if 2 volume of acetylene is required, or you can say is using 5 volume of oxygen, so 1 volume of acetylene will be using 5 by 2 volume of oxygen. And how much do we have here? You have 200 centimeter cube of acetylene. So 200 centimeter cube of acetylene will be using 5 by 2 times 200 volumes of oxygen. So we'll quickly solve it out. So this would be 500 centimeter cube of oxygen. So this is the first part. Find the volume of oxygen used in this. Then in the second part, we are supposed to find out for carbon dioxide. So we'll do something similar. So this would be C2H2, twice of C2H2 plus 5 O2 giving us 4 of carbon dioxide plus 2 of H2O. So we'll work for carbon dioxide now in the similar way. So 2 volume of acetylene is giving me 4 volume of carbon dioxide. So 1 volume of acetylene will give me 4 by 2 volume of CO2. So 200 centimeter cube of acetylene will give me 4 by 2 times 200. So we'll cancel this 100. So this becomes 400 centimeter cube of carbon dioxide. Okay, so this is your first part of the question. And that's it. You don't have to find anything else. Okay, moving on to second part. A gaseous compound of nitrogen and hydrogen contains 12.5% hydrogen by mass. Find the empirical formula of the compound. Okay, so for empirical formula questions, I'll have to use a separate page so I can I can make a chart for you guys. So the chart that you'll make would be containing elements. Then that would be percentage that is given in the question. Then atomic weight. Then along with that, relative number of atoms and simple ratio. So you'll have to make this chart for all the empirical formula questions. Okay, so in this question, if we come back, in this question we have a gaseous compound of nitrogen and hydrogen containing 12.5 hydrogen by mass. Okay, nitrogen and hydrogen. So you have nitrogen and hydrogen, and 12.5 is hydrogen given to us. So if you subtract 100 from that, you will have 87.5 for this. Then atomic weight, we know that for nitrogen is 14 and for hydrogen is 1. Then relative number of atoms. Okay, in relative number of atoms, take an estimate. I am using a calculator with me. For you, you can use. You'll have to use regular calculations to make the video a little bit quick. I'm using a calculator. So if I calculate this, this would be 87.5 divided by 14, which is giving me 6.25, and 12.5 divided by 1 would give me 12.5. So the simple ratio, if I think about it, is technically 1 is to 2. Now, if it is 1 is to 2, that means you have 1 of nitrogen atom and 2 of hydrogen atoms. And this is your empirical formula. And this is your answer. For any question, if you're not sure how we are getting these answers and you need help, please drop a message in the comment section and I will help you out. I'll help you understand what is the concept behind each question. Now, let's move on to next question. So question 2 is done. We're moving to question 6. Question 6 says a compound has the following percentage composition by mass. Then we have carbon 14.4. Okay, it is again empirical formula only. So I'll make the chart first. This is question number 6. So what I'll need is, I'll need elements, percentage, atomic weight, relative number of atoms, and simple ratio. Now let me make the whole table. Now I do have carbon with me. What else did they say? So you have a compound has the following percentage composition by mass. Carbon 14.4, hydrogen 1.2. So carbon 14.4, hydrogen 1.2, and chlorine 84.5. Determine the empirical formula of the compound. Work correct to one decimal place. Okay. So chlorine 84.5. So we have chlorine 84.5. So atomic weights, we know that for carbon is 12, hydrogen is 1, and for chlorine is 35.5. If we think about the relative number of atoms and you divide this, so I'm getting 14.4 divided by 12, and I'm getting 1.2. Now 1.2 divided by 1 would be 1.2, then 84.5 divided by 35.5, I am getting 2.38, and roughly you can take it 22.4. Sorry, 2.38. So roughly I'm taking it 2.4. Now the simple ratio, if you think about it, is 1 is to 1 is to 2. So 1, 1, 2. So your empirical formula will be, so first write CHCl and then write, so 1, 1 and 2. So your compound formula is CHCl2. Okay. Now let's see what is part 2. So this was question 6 first part. What is question 6 second part saying? It says this is done. The relative molecular mass of this compound is 168. So what is the molecular formula? Okay, this is interesting. So let's calculate it. So this is the second part. Now empirical formula weight. First we'll find that. Empirical formula weight. So what is empirical formula? CHCl2. So that means 12 plus 1 plus 35.5 into 2 would be 71. You add all that up, you'll get 14, you'll get 84. Okay. So now use the formula N equals molecular weight divided by empirical formula weight. So the molecular weight they gave is 168. So 168 divided by 84, that is just 2. Okay. Now, molecular formula that they asked you. So molecular formula is that you have CH, Cl2 empirical formula, whole of N. Now this N is the N you just calculated. So you put that in the formula. So now it becomes CH, Cl2 whole twice. Now open the brackets. You will get C2H2Cl4. And this becomes your molecular formula. Okay students, let's move on to question number 10. So the question number 10 says a sample of ammonium nitrate when heated yields 8.96 liters of steam. Then you have the equation given. What volume of dinitrogen oxide is produced at the same time as 8.96 liters of steam? Okay, so we'll be talking about these two compounds. Now I don't have enough space here, so I'll be moving on to the next sheet. Or okay, I'll just try and do it right here wherever I get space. So what is the equation given to us? So the equation is given, so I'm not writing the whole equation, I'm just picking up the information from here. So I see two volumes of steam, so we'll say two volume of steam is coming along. So I'll just write 2V of H2O is coming along one volume of dinitrogen oxide. So one volume of water or steam will come along with half volume of dinitrogen, and they are talking about 8.96 liters. So 8.96 liters of steam will come along 1 by 2 times 8.96. So if I quickly calculate that, that should come out to be 4.48 liters of N2O. So this is the answer for the first part. Then second part is not in the syllabus, I have cut that out. Then the third part, determine the percentage of oxygen in ammonium nitrate. Okay, first of all, what is the total mass? Figure out the total mass. So the total mass, if we, I'll just write it here. So I have NH4NO3. So N is 14 plus hydrogen is 4, then again 14, then 3 times 16 is 48. Okay, if you calculate this, this would turn out to be, this is 28, so 32 plus 48, you'll end up with 80. Okay, now we'll calculate over 80. So we have three parts, or you can say three molecules of oxygen. So 3 times 16 is 30 is 48. So 48 divided by 80 times 100 will give you the percentage of oxygen in this compound. Okay. Okay, then let's move on to question number 11. Question number 11 is again empirical formula. So I'll be making the chart on the next page. A compound X contains 4.8% carbon, 95.2% bromine by mass. Okay, we are on question 11. So we'll again start with the same things. You will write element, percentage. You'll also write atomic weight. Along with that, relative number of molecules, number of atoms. Along with that, you'll write the simple ratio. Okay, so what all do we have now? Let's see. So question number 11, I have carbon and bromine 4.8 and 95.2. 4.8 and 95.2. So 4.8 and 95.2. So what do we have? We have carbon and bromine, and then the atomic weights for carbon is 12 and for bromine is 80. Now I have the basic information that I need. Now let's see what do I have. So let's quickly calculate this. This would be 4.8 divided by 12. I should get 0.4. And then 9.5, 95.2 divided by 80, I'm getting 1.19. Then simplest ratio, if you think about this, the simplest ratio would be 1:3. Okay, now let's make the formula. So empirical formula would be CBr2. Now let's move ahead with the question. What does the next part of the question say? So next part of the question is saying, if the vapor density of the compound is 252, what is the molecular formula of the compound? 252 is the vapor density. So second part is vapor density is 252. So what do? We use the basic understanding. So first we'll calculate the empirical formula weight. So empirical formula weight is 12 plus thrice of 80. So this will in total become 12 plus 240. So that would be 252 AMU. Then we'll calculate the relative molecular mass. So that would be 2 times vapor density. So that would be 2 times, and they have given 252 as the vapor density to 252. So if I calculate that, this would become 504 AMU. Now we'll use the basic formula that we did in one of the previous questions. That was N is equals to molecular weight divided by empirical formula weight. Molecular weight divided by empirical formula weight. So molecular weight, have we calculated molecular weight? Oh yeah, relative molecular weight right here. So this is 504 divided by empirical formula weight 252. So this is just twice, so 2. So now your molecular formula should be, now we got CBr2. So CBr2 whole n. So CBr whole twice, C2Br4. This becomes your answer. Just 1 second. Oh, this was 3, right? So this is CBr3. I did multiply it by 3. This is fine. Then this should be 3 right here. This should be 3. And this becomes a 6. So CR2BR6. Okay. Now moving on to the next question, students. Let's see what is the next question. Oh, okay. Now, one question I missed out was 11th third part. Name the type of chemical reaction by which X can be prepared from ethane is substitution reaction. Substitution reaction. Then moving on, question number 12. Determine the empirical formula of a compound containing 47.9% potassium, 5.5 beryllium and 46.6 fluorine by mass. Okay. So I'll just take a note of it on for the next page. If you want to still take a look, just take a screenshot of this, and I'm moving on to the next page. And this was question number 12. Okay, I do have the question in front of me as well. So question number 12, so that I don't have to go up and down again, it's wasting a lot of time. So I have the elements, percentage, atomic mass, then relative number of atoms, and simple ratio. Now I'm taking reference of the question from my book itself. If you want to go back, please download the question paper on your screen and then take a look from that. So the question gives me potassium, beryllium and fluorine. The percentages given are 47.9, 5.5 and 46.6. And the atomic weights given are 39, 9 and 19. Okay, let's quickly start calculating that. So 47.9 divided by 39 is giving me 1.2. 5.5 divided by 9 is giving me 0.6, and 46.6 divided by 19 is giving me 2.4. So the simple ratio that I have here would be 2, 1 and 4. Now let's calculate the formula. So K, B, E, F. So 2 of K, beryllium I have 1 and fluorine I have 4. So this is my empirical formula. Now let's see, is there anything else in question number 12? We just have to calculate the empirical formula and that's it. Now let's move on to question number 14. Calculate the percentage of sodium and sodium aluminum fluoride. So you have Na3 AlF6, correct to the nearest whole number, and the values are given to you. Okay, this is easy. We'll just do question 14th right here. So question 14th is giving me yeah, we are supposed to calculate the molar mass. So that would be for Na3Al F6. So that means 3 times for sodium it is 23 given, plus aluminium 1 times 27 plus 6 times 19. So if I calculate that real quick, okay, if you add all of that, you would end up with 210 AMU. Now use this information ahead. So we are calculating percentage of sodium. So percentage of Na would be, so Na, how much do we have? Na 3 times 23. So you have 69. So 69 divided by 210 times 100 will give you the percentage. If you want, I can quickly calculate that too. So this would be 32.8%, and approximately you can write 33%. Okay, students, this is question number 14th. Moving on to question number 15th. So I have, the question says 560 ml of carbon monoxide is mixed with 500 ml of oxygen and ignited. The chemical equation of the reaction is as follows. This is the equation. Calculate the volume of oxygen used in carbon dioxide formed in the above reaction. Okay, this is easy. So you have 2 carbon monoxide plus oxygen giving you 2 CO2. So this means 2 is to 1 is to 2. And the info, or what else do we have? 560 ml of carbon monoxide. So 560 is to 280 is to 560. So volume of oxygen used here would be 280. Volume of oxygen used is 280. And volume of carbon dioxide formed is 560. Okay. That's it. That's it. That is required in the question. Alright, let's move on to question number 18. We'll just solve it right here in this space. Okay, calculate the percentage of nitrogen in aluminium nitride. So that is ALN. That means 27 plus 14, which would give me 41. Now, if you are calculating the percentage of nitrogen, that would be 14 divided by 41 times 100, and that will give you the information. Now, define atomic weight. You can directly take the definition from the book. If you have any doubts about that, I will be happy to help you out. Now, I understand that all of this looks like a bit of a mess, but towards the end, I will attach all the answers in a more systematic manner so that you are able to revise properly and understand what's going on. All right, students, let's move ahead. Move ahead with question number 21. So in question number 21, second and third part are not in the syllabus. Now let's look at the remaining three. So Gay-Lussac's law is related to combining volumes of gases. So the answer would be D. Then the fourth is diatomic, that is related to hydrogen. So your answer is E. Then empirical formula is related with simplest ratio. So your answer is A. Then fill in the blanks. Only the third one is in the syllabus. This is the same formula that we have discussed today in a few questions. Molecular mass equals N times empirical formula. Empirical formula. Now, moving on to question number 23. So the first one is, among the following nitrogenous fertilizers, which is the best fertilizer? So urea is always considered the best fertilizer, and the formula for urea is C, that is NH2CONH2. Moving ahead to the third one. So Gay-Lussac's law is applicable only to gases. It is not applicable to solids or liquids. It is only applicable to gases. Now moving on to the unit of vapor density. So vapor density is none of these, because not gram, ml or centimeter cube is the unit of vapor density. So we'll just quickly say none of these. Moving ahead to question 5th. The relative molecular mass of Na2S2O3 dot 5H2O. Okay, sodium thiosulfate. Now, what we'll do is, this is a homework for you. So we have done similar questions today, that is calculating the molecular mass. So this is a homework question for you. And the next one, the volume of oxygen required and volume of nitric oxide formed when 100 ml of ammonia is catalytically oxidized according to the balanced chemical equation. And then you have the equation. Okay, these two questions are homework for you. Please do let me know your answers in the comment box. We have done similar questions today. So I am assured that you will be able to solve these questions. If you're not, please do mention that in the comments. And if you do, whatever answer you got, mention that in the comment section below and I will revert back with the correct answer. All right, students, this is it for today's session. This was test 5 and we did solve so many questions together. If you have any doubts in any particular method or you want to practice more questions on a similar method, please do let me know. I can share more question papers with you. So for the time being, we'll move ahead and tomorrow we'll have test number 6. So make sure that you join the Telegram channel and get the question paper up front before the video is released. So thank you so much and please do subscribe and share the video with your friends and family.